Hello everyone. I'm gonna discuss about KNN algorithm, which is a supervised machine learning algorithm, which is used to predict the class of a given sample data. Uh, Here in this video, we are going to predict whether a person's tumor is malignant or it is benign. So for this, very first, we are looking at the code of a KNN algorithm, simple KNN algorithm. And this KNN algorithm has some steps. The first step is here we have the finding of shortest distance between the trained data and the testing data. Okay, so after finding the shortest distance, we are here. We are here define the value of k. Uh, After defining the value of k, what we are going to do? We showed them, and here as value of k is 1, so only the shortest distance with the class only going to be sh short, and as it is only a single class, so the automatically the predicted class will be also the same. So here we can see it's predicted class on the console screen, that is predicted class equals to 0, where we used two classes that are zeros and ones, as it is binary classification. So now we are going to see the actual code for the tumor classification. So in this we have used some libraries like numpy, pandas. NumPy used for the numerical and data handling, and also we import some load breast cancer. In this we loaded the uh, training data. Then here we have train test split, in which we split the given data into two categories, which is training and testing. And standard scaler also we will going to discuss about it later. That it is used to scale all the data in a particular identical scale, so to avoid the ambiguity. So, and here it is KNN classifier. Here we load the data into X, and the target value is into Y. In X we are putting the features of the data, features um, like we have studied in iris dataset, sepal width, sepal length, petal width, petal length. These are the features of the given data. So these are we have put into the X, and the target values here are malignant and the benign. So we put them into Y. Then we are here splitted the provided data into two categories: training data and the splitting data, training data and testing data. Training data will be used for the uh, training of the agent. It provides the agent to learn from the data, extract some patterns, some new information, so that when the testing data is provided, it automatically operate on it and predict its class, predict able to predict its class. So then we have here standard scalar function. Standard scalar function is used uh, because we have too many samples of data. So and in KNN algorithm, The very first thing is to find the Euclidean distance, and if the scale of all the data set data can be different, then there would be some ambiguity or error. So to avoid them, we use here this standard scalar function. Here we have fit transform function and transform function. So both have their own use. Like fit transform function is used for the training data, and transform function is used for the testing data. It just applied the information or the rules it learns it learned from the training data. It just applied on the testing data, the transform function. And fit transform function, it uh, extract information by statistically analyze the data, and after that it applies on the data. So this is some differences. Then we are here with K-neighbors classifier. It is a function that is going to be called for calculating the distances, minimum distances between the 2 points, so that we can predict the value of the given data. Why predict? Here, why predict is predicting the value of test data. Then we have here confusion matrix. Confusion matrix is like a tool. Mm, it is a tool which um, tells us that the predicted value or output is correct or incorrect. So it has it has a particular structure, like in binary classification. There are only two classes, so it has uh, in its structure four terms like true positive, true negative, and false positive and false negative. So true positive and okay, these values give uh, are used in the giving classification report. So classification report has some terms like precision, recall, F1 score. These are calculated from the structure of the confusion matrix, and these terms like in the classification report are used to give feedback to the agent. It is like a feedback for the agent, and um by looking at this, it improvises itself and next time tries for the better. Precision means the predicted output, um, how much close the predicted output to the actual value. That is a precision, and its formula is also like uh, true positive, and the ratio of to true positive plus true negative. It's also in similar way. They also have their formulas. F1 score is the mean of precision and equal. So all these terms are useful for the feedback of the agent. So now here we have provided a sample data of a patient and scaled them scaled them by the scalar standard scalar function, and because it is testing data, so we have used scalar dot transform function. And from this we have predicted the value. We can see the output for this. That is the confusion matrix for this. This is TP, this is TN, FP, and FN. And the classification report for both the classes, malignant and benign. And the predicted class for the new patient sample, that is benign. So like this, we can use this algorithm, and in the similar way, it uses used in many of the real life applications. Uh, uh, to classify the testing data classes. So thank you.